So, as Jonathan was saying, I'm based out of the Colorado office. So if you guys are working at like midnight and you submit a ticket or something, I'm probably the one that'll be helping you. Try not to work at that time, but if you have to, you have to. Yeah, I'm usually up. Okay, so we saw a moderately complex model from Joe. We saw a horrendously complex model from David. I'm going to take this back a step to more of a simpler model. Okay, kind of give you the basic overview of things you can do and how you would implement COL in Scheduler, and kind of some of the case studies you might consider looking at. Okay, so the goal of Minemax Scheduler is to maximize the NPV for complex projects while honoring multiple constraints. Okay, so in that, we need to bring in the financials. We saw that in the various other presentations. We have to define our constraints, whether those are processing constraints, blending constraints, etc. And then Scheduler is going to go through using Cplex to optimize to find the highest NPV solution for you. So some key decisions. These are kind of the decisions that you're going to start out when you're building your model that you want to look at. Product choices. So for this example, I'm going to have ROM tons, so straight feed out to product, a wash plant, and then an upgraded wash plant. Okay. Within that, we're going to have blending constraints. So I'm going to be mainly looking at sulfur and ash for the product. You can look at equipment purchase. You can look at CapEx for the new upgraded plant. And inherent to Scheduler, you're always going to be looking at sequencing of areas. Okay, and that's kind of the main inherent choice of Scheduler, is where do I mine and when. Through that, it's going to be doing that sequencing based on the precedence we tell it, as well as the other constraints. In this case, I've got a mining constraint for my coal, how much I can wash at my existing wash plant. You see that the upgrade there is currently 0 for the wash upgrade, so I'm considering enhancing that upgraded plant. I've got a dragline constraint. I also have sulfur and ash blending constraints on my run-of-mine coal. Now, if I send it through the wash plant, the upgrade plant, I no longer have that blending issue. It brings it into spec for this example. Okay. Now, how are we going to import this data? This is where it gets more interesting for COL. Generally, Scheduler is designed for a traditional block model with benches. So if you've worked at a metal mine, you have your benches, it has its grades, it has its tonnages, etc., in a bench-by-bench format. Okay? The way we handle this for COL is there's kind of 3 options. You can bring in your COL that's been, your COL model that's been turned into a traditional block model. Okay? I just did this for a client. It involved a decent amount of Excel work, but they were using a strat model, and we turned it into a bench model. A lot of times clients will just be able to, from their software, export a bench model directly. That's generally the nice and easy method. Now, the second option is once we have that traditional model, you can leave it flat, mine out the material through strips using precedence. If you have a very large model or several deposits, and you don't necessarily want to have all these individual strips as precedence in your model, mainly for speed of solving, then the next idea is we take those models on those planes. If you have several areas, we would do this independently. You actually flip the entire thing on its side. So I now have strips oriented vertically in a stack that Scheduler then progresses through these strips as though they were benches. And this can greatly speed up the solve time while also reducing the precedence that you need. Okay, and you can do that for the multiple panels. It still has the ability to do all the blending, all the sequencing choices, all the CapEx, all that's still in there. Okay. The third option is the Polygon model. So this is actually newly released in Scheduler. We've had internal versions that clients could use as needed in order to bring in their reserve sets with polygons in Scheduler. Now, this is an example here of what that might look like for a strip-oriented operation. Only downside is here you need to make sure that you have structured that data correctly, where you have large enough polygons that you're not going to overwhelm Scheduler with the choices. as David was talking about earlier. Okay, and so going forward, I'm going to be talking about this Polygon model that I've made. So in here, I have 3 different products, essentially, or 3 different revenue streams. We have our ROM coal, okay, and that's going to be at one price. We have our wash coal that's at the same price but doesn't have the blending constraints that the ROM does. We don't have to meet the ash constraint. And that's going to be the one that's the biggest issue in here. And then I have a coal wash upgrade that produces a superior product that we can sell at a higher price. Okay, and so now Scheduler is going to see those 3 revenue choices and decide where to send material based on availability and blending in order to maximize that NPV. And we have a mining cost, processing cost for the ROM, for the wash, etc., for the upgrade, dragline, as you can see here, and shovel. So you'll notice that we haven't talked about shovel before. Shovel is a mining process. It's predetermined, meaning I know how many tons are going to shovel versus I know how many tons are going to dragline. In Scheduler, we have these 2 different types of architectures: predetermined destination, predetermined process, and alternative decision. So the choice between sending material to ROM or sending to the wash plant is a decision that Scheduler needs to make. However, if I'm mining a certain type of waste, it is going to be a shovel process because I've predetermined that. You're going to want a blend of these mining processes and decisions in order to decide where Scheduler will be sending material, in order to properly control your mine, apply your costs, those kinds of items. So setting these financials, then I have my individual strips. So we saw that this was a flat plane, right, with all these strips. Another key feature that we have here is this lag, this min and max lag. So with this min and max lag, I can properly control the advance of these strips in order to make sure that the dragline has the room it needs, and it has to move on before I can be mining the coal. Otherwise, I can't be spoiling over. Okay? So I can set lag on these polygon benches in order to ensure practicality of my schedule to get previous equipment out of the way before the coal equipment comes in to do its job. You can also force minimum lag. So if you have a high wall that maybe has some faulting or has some weaker structure, you can tell Scheduler that it needs to bring that down before it can move on in order to keep mining. Okay, so that's kind of what we have here. Is we have enough lag to get the equipment out of the way, and then we also have lag to ensure that the high wall is coming down at the appropriate rate. Above that, we have those constraints that I was mentioning earlier. So we have the mine constraints, the drag lines there. The ash is going to become very important when we look at the second scenario. Okay, so I have 3 scenarios that I want to talk about, and then a bonus 4th scenario. So the first scenario is going to be a base case that I ran with ash at 4%. Okay, and so that would be coming from what you're trying to sell as a product, saying, hey, this needs to be at 4% or lower in order for me to sell. The second one that I ran is, what if our contract changes or the demands of the power plant change, and I now need to have ash below 3.8%? What would that do to my schedule if that had to occur today? Okay, and so we're going to look at what that causes between the 2 scenarios with that one change. It may not seem like a big change, but it could drastically affect the scenario. Next, we're going to have a wash plant upgrade that's going to increase the capacity that I can send through the wash, as well as it's going to produce a higher value product if I upgrade in order to sell at a higher price. And we get around that ash because we're doing through the washing process. Then once we've looked at those 2 comparisons, we're going to have a final scenario that combines both. What if we have a lower ash with a plant upgrade? Okay. These are the kind of scenarios and decisions you can run in Scheduler very quickly. You know, I just take my first base case scenario, clone it, make a little change, clone it, make a little change, and then I can present all of these options and look at these different sequences to see, does a small change here in a sensitivity completely change my future schedule, in that case, it may not be that robust of a schedule for the future. Okay, so first one here, I have my normal ash, max of 4, and then I have a new restriction at 3.8. And you'll see that my coal profile drastically changes in how much I can produce as product. You know, we're cruising along there in the first example. My ash is up around 4%. My sulfur is down there at the bottom, never really hits its constraint. And all of a sudden, as soon as I change that max constraint, it can't produce enough product to meet my crushing maximum. Okay, so I have a much lower MPV here. The next one I wanted to look at was, what if I have a plant upgrade? Plant upgrade might get around this issue, okay, but I want to compare it against the base case first. So the base case had an NPV of $817 million for this scenario, given the information that I gave it. The plant upgrade cost about $25 million to give me a little extra capacity and also produce a higher product. That increased the NPV to $836 million, including the purchase price of the plant. You'll also notice that it didn't purchase the plant until 2026. I gave it the option to purchase that plant whenever it wanted. So it can dynamically choose when to implement that plant upgrade. Now this NPV is actually only a 9% IRR. That may not be enough to get over your internal capital hurdles. There might be other places that's better to spend that capital and better to improve your mine. Okay, so this would be one scenario among many for capital choices I might look at. In Scheduler, you can also put many capital options, tell it what your total capital budget is, and let it pick in a single solve which capital option would be the best ones to choose. Okay, but for this case, I wanted to give it a single option. So now the question is what happens in the lower ash case if I also allow it to buy this plant upgrade? Now remember, if I can send more material through the wash plant, the lowering of that ash constraint on my ROM won't affect it as much. What happens there is my NPV now comes back up to $832 million, which is higher than the base case, lower than just the plant upgrade. But you'll notice that my coal is now fairly uniform. You have two little gaps there. They could probably spend some more time in Scheduler to get those quantities up. But what this shows you is if I'm trying to choose between, this capital, should I spend this money on this plant, from an NPV perspective, maybe not. But if I'm uncertain of what my contract might be with my suppliers or with my consumers for that coal, and they might be lowering my ash restriction, well, I might do this plant upgrade, even though the NPV is only about 8%, 9% IRR, in order to avoid the risk of not being able to meet my specifications in the future. Okay? So on a very simple model that doesn't take a lot of time to put together, this is the kind of analysis you can do to prove that you're creating a robust schedule versus something that might be tipped over if a single cost is out of spec or a single grade is off, a single constraint changes. Scheduler allows you to run a lot of scenarios to make sure your schedule is robust and can handle a lot of changes. Okay. And so are there any questions about kind of the simple scenario work and optimization that you can run in Scheduler to prove how robust your schedule is?
I've got a question about the Polygon inputs.
Mm-hmm.
So I know in the past that that's been available as kind of optional extra, I guess.
Yeah.
So you're saying that's now a standard feature?
In 7.3.3 that came out last week, it is now a standard feature and has a standard interface in the import. So if you go to import, you'll now see there's an extra option on pits. So yeah, you can start playing with it today commercially and not have to worry about your coworker having the special internal version that allows you to do it.
And the other point was that it only took a very specific file type in the past, so I assume it's more generic now.
Yeah, anything that you could use in the dump, so DGDs, DXFs, Datamine files, you can now use for the pits as well. They'll take whatever. Okay, any other questions?
The projects that you've been running over the last few weeks,
Mm-hmm.
the invoice for all that typically you would follow that cold what they've been using as the data.
Yeah, so last week I worked with a coal customer and they had a strap model, and essentially they exported out something I believe they called primals. I'm not sure if that means anything to you. It didn't really mean anything to me, so I don't do a lot of coal work. And I was able to take that in Excel and essentially just, now that I know how to do it, it took me about an hour to figure out how to do it, but now that I know I can do it pretty quickly to any project, we quickly converted that to a bench model. And now it comes into Excel, no issue. They look at it. They know what it looks like. It looks essentially like their model. It just happens to have been, squished up and down a little bit. But as far as scheduling goes, it's still the same thing. They can still associate those time periods with the same blocks. All the same names are there. We just had to squish things around a little bit. The other case that we see a lot is with this custom Polygon importer. It used to be internal. Not necessarily internal. If customers, key customers, hey, this is my problem, we would hand it out and be like, here, this is how you use it. But we're seeing more demand for that, especially in the coal industry. And so we now have this where you can take your polygons as well as a reserve file that's standard from like your strat model and bring it into Scheduler with no problem. Yes, sir.
Just rewind it with the full robustness.
Mm-hmm.
How do you handle the variations of the variables that you are varying?
Yeah, I mean, so essentially it's kind of up to you like in Excel, right? But you can generate tons of scenarios and then compare which phases are being mined when. Are my KPIs being hit at the mill? Are my KPIs being hit at the wash plant, et cetera? And see, okay, if I start varying my processing costs by 10, 15% either direction, are my KPIs changing dramatically? If I'm varying my mining costs, are my KPIs changing dramatically? And, it's going to change. You're changing a cost. The answer is going to change. The question is, are you all of a sudden, instead of mining pit 1, all of a sudden you're switching to pit 2? In which case, if you just minorly change something and you're switching between all these different pits, then those schedules may not be robust for economic change. And I would want to make sure that my costs are very accurate in that area. Whereas you might have a different cost that you start changing or a different constraint. I can change that, for this data set, I can change that sulfur constraint all over and nothing changes. It figures out the blend is available, the material is available to hit the blend for the sulfur. And so it's kind of one of those things, okay, I vary it. If I see, like in this case, ash, I would want to be very certain about what I think my ash requirements are going to be in the future. Right? If I think that they might be lowering, then I'm going to want to make sure that I have a schedule that can handle those ash constraints coming down an uncertain amount. So, but it's up to you to do that analysis in Excel afterwards, but Scheduler can run all these scenarios for you sequentially. Okay, David?
Matt, when you're dropping, you change the lower tonnage.
Mm-hmm.
How do you get Minemax to deal with the fact that you've probably got coal seams now and you've got rice that can't fit into that blend?
It was available to waste them.
So you had to waste coal.
Yeah.
It's like monitor how much coal gets wasted versus how much better.
Yeah. It ended up being a minimal amount just because it couldn't find the blend and just ended up with a lower on production period. But yeah, you can set it up so Scheduler can waste it if it's just so out of spec that we can't do anything with it.
The stockpile option, so you can blend.
You can set Scheduler up to stockpile. I did in this case. This is kind of like energy coal model, and generally they don't like stockpiling that for very long because it might catch fire, at least in the U.S. But you can set it to stockpile. I spent a summer as an intern up in Wyoming, and we would very often see in the morning after a rain, there'd be a little pile of like coal that fell off the truck and be on fire right there next to the haul road. So you can turn stockpiling on. I just didn't have it in this model. Any other questions?
The other interesting thing you mentioned was potentially rotating the model so that now all of a sudden you don't need strip precedents because you're just mining using depth, automatic precedent, I guess.
Yep.
Is that just a spreadsheet?
I've just
Or is that an actual feature that you?
No, I've just done it in Excel using sine and cosine. Or sorry, not Excel, in Scheduler using sine and cosine. So just take the existing coordinates, pick a point to rotate around, and rotate the whole thing 90 degrees. The one disadvantage there is you don't necessarily have the lag that you had on strips between the strips. But if you don't need lag, it definitely will solve faster than laying it flat and putting all the precedents in there, just because of the way the structure of those constraints are. But yeah, no, so I've just done it in Scheduler using a little trig from the old high school days.
On the bench
So no, on the whole coordinate system. So on X, Y, and Z. So you just take the whole coordinate. Same thing with rotated models. So if you have a rotated block model that's not on north-south, you can do the same thing in Scheduler, just a little trig to rotate it so that the pictures look good. Any other questions?
Right, thanks for that.
Thank you.